Hello learners, welcome back. Welcome back to the world of group theory class course day 13. So today we see about the vibrational modes IR and Raman activity for the characterized table. So learners, are you ready to apply the group theory? Today we will use the character tables to find the IR and Raman active modes. Before that we calculate the expression for irreducible. So we find this table for the which one is contributed and which one is unshifted. So using this value, in previous video we see about the reducible representation value. These are the value for contributed character for unshifted ions. So for that using this value we calculate this table for the reducible representation. For the C2V, the unshifted calculator is calculated here. We consider for the C2V, the best example one is water molecule. So this is the water molecule. This one is A and this one is B. So this is the water molecule and this is the 3 axis. This is Z axis. This is X axis and this one is Y axis. So this is the we see for the best example for the CTV point groups. Using that one, we find the unshifted values for the E, C2, sigma V and sigma V dash. So for V, what is identity? It's doing nothing to the molecule. So all the 3 atoms are unshifted here. So the value for the unshifted value for E is 3. For that C2, what happened? The molecules are rotated up to the 180 degree. The A go to here, B and B go to here. So that these 2 molecules are shifted. The O only unshifted. So number of unshifted molecules for C2 is 1. And for sigma XZ, this sigma XZ is the reflection. So reflection by this one is the plane of paper. So all the 3 atoms are not unshifted in base with respect to sigma XZ. So this one is 3. And for sigma Y is that in the what happened in the sigma Y is that in the sigma Y is that we have to cut this molecule with and reflect each other. So these 2 are reflect each other. So these 2 are move each other. So only of this and only not unshifted. So this one is move on. So we know about the contributed character. What is the value of E? That is 3. And what is the value of C2? That is -1. What is the value of sigma XZ? Sigma XZ is 1 and sigma XZ is also 1. So we multiply it with it together and we have the reducible representation. And then next we have calculated to the order of the characterized table. What is the by using the great orthogonality theorem? The add of square of identity value is equal to the adder. So 1 square plus 1 square plus 1 square plus 1 square is equal to 4. So order of the characterized table is 4. So we have to find the number of reducible representation functions expression by using this one. So for T1 we multiplied this one with this A1 value, this A1 value 1 by H means 1 by order, so 1 by order into 9 with respect to 1 into 1 into 1 into 1 plus -1 with 1 into 1 into 1 plus 3 into 1 into 1 into 1 plus 1 into 1 into 1. So we get the TA1 value 3. So like that we get the values of TA2 and TA_B1 and TB2. So we by adding together we have find the total irreducible representation here. The value of TA1 is 3. The value of TA2 is 1, so A2. The TB1 is 3, so 3B1 plus TB2 is 2. So this is the we obtain the equation for irreducible representation. So what we get? 3A1 plus, so before that we have to know about the translation modes and rotational modes. How we calculate the translation and rotational modes? By using the character table, to calculate the translation mode, first we see about which one has the x and y and z value. So which are the values getting this value is applicable to translation mode. So what does the value have? A1 has, B1 have, B2 have. So A1 plus B1 plus B2. So don't care about this. Then rotational modes. For rotational mode, which of the value has or represented value, we taken this for rotational modes. So A2 plus B1 plus B2. So for calculating this vibrational mode, we have the formula here, that is irreducible representation minus translation mode plus rotational modes. So these are kept in the bracket. So we add the two first. A1 plus B1 plus B2, A2 plus B1 plus B2. So by adding we get the A1 plus A2 plus 2B1 plus 2B2. So from the value we have to minus the irreducible function value we obtained before. So for this one is multiplied by minus. So we have to cancel A2 and B2. We obtain the 2A1 plus B1. So by adding the before numerals, we get 2A1 plus B1. What happened? What do you get? 3 vibrational modes. And also we get the expression also. So for checking the IR and active modes, for checking the IR active or not active, we have the two rules. Before that, what do we get? 2A1 plus B1. For that element, for example, here we have A and B1, A1, B1. So the A1, B1 in the characterizer table, it have X, Y, Z value in this session. It have the IR active. If it's had quadratic function like x square plus y square, z square plus x, y, z, x, y, x square minus 1, then Raman active. So check, we have this vibrational mode equation 2A1. So what happened for A1? We have z here and also we get what? Z square, x square, y square also. So, and for B1, we have x here and also we get here x is that. So, it has both the condition, one IR active for Raman active. So, this characteristic table has both IR and Raman active. So, for that in CSER point of view, we have the options be like, suppose we have, suppose they ask the number of vibrational mode. So what is the number of vibrational mode? The 2A1 plus B1. So 2 plus 1 is equal to 3. So the option is 3. In such a case, they ask is higher active or Raman active. What is this? For this case, it has the both active. So option C is the correct answer. This is the one problem for you try. You try to solve this problem and put the answer in the comment box. Okay, learners. Today we learn about the how the IR and Raman active modes for the characterizer table. In tomorrow we see the another interesting topic. Thank you for watching. Thank you.